B, our default is ATM, okay? Our default pressure unit is ATM. Okay, and that stands for atmospheres. Okay. So, what is the volume? Well, it says 3 moles of a gas are placed into a 4.55 liter container. The 4.55 liter, that's going to be your volume. Your N value is your mole quantity. So remember, this is the moles, right? That's the moles. And it says right there that it's 3 moles. Keely, can you check on your sister, please? Lily, what are you doing? Okay, you want to bring it to me? Okay, your R value is dependent on what the pressure value is. So dependent on pressure units. And the pressure unit in this case is 245 C. So we're going to do 245 plus 273. So no, I don't want that. I want a calculator. Oh my God. I hate this computer. Hate it. All right, what was it? It was 245 plus 273. $518, okay? So it's 518 Kelvin. So you can clearly see it's a crap load of variables, probably more than anything you've ever dealt with in math class. But the concepts in math and in algebra and chemistry are identical. So what we're going to do here is we're going to use this equation, but we're going to solve for this variable because that's what we're looking for, right? So if we take PIVNERT, and I always circle the variable that I'm looking for, okay? So we're solving for this one, which means I have to isolate it, which means I need to move V to the other side. So when V happens, it gets divided on both sides by V. These cross, right? And that gives you P equals nRT divided by V. As a matter of fact, I will go ahead and just solve all the rest of those for you right now. Missing one. nRP. Oh, solve for temperature. There you go. So there's three of them. PV over RT equals N, PV over NR equals T, and then PV over NT equals R. This one right here, though, you're not going to use. I don't even know why I wrote that out, because it's a constant, so don't worry about that one. But you use these two, and we solve for volume. Oh, volume right here. That's how you solve for volume. Dang, I saw us 4 people. Whew. Y'all saw all the variables and ran. What's up with that? What's up, Cedric? How you doing, buddy? How's your weekend? All right. Now, let's go ahead and back and solve for this one. All right. So, those are our variables. This is our equation, right? So what do? You take the numbers for the variables and you plug in the numbers, right? Good. Unfortunately, there was 0 sports on, Cedric. And I about Netflixed out my list. So I couldn't spend time outside either. It was too rainy. All right, so let's start solving for this, okay? So we're going to write out P equals, all right? And we're going to do N. My N value is 3 moles. Okay. My R value is 0.08206. Okay. My T value is 518. Okay. Divided by my volume, which was 4.55 liter. I've got a key for this around here somewhere. Probably need to find that as opposed to keep calculating numbers, but that's how you set it up. And let's see, 3 times 0.08206 times 518 divided by 4.55. Comes out to 28.0266461538, or 3 sig figs would be 28.0. Pressure is 28.0 atmospheres. So that would be like, if you were standing in that, okay? That would be like if you were standing at 28 times the atmospheric pressure of Earth. 28 times. That's bananas. That would crush you. But gas molecules, it doesn't. It just compresses them. But yeah, you wouldn't be able to withstand 28 times your atmospheric pressure. No, not really. Gram value. Okay? So if we have a gram value, that means that we can find out moles, which means this is not a PV over T question or a combined gas law question. This is a Pivner question. So what is it asking us to find? It's asking us to find the temperature. So we're solving for T. So let's do that first, okay? So we have PV over equals nRT. We're solving for this one, which means we're going to divide both sides by N and R. Those cancel, which leaves you with PV over NR equals T. All right. So we have P, V, N, R, and T. Can somebody tell me what the R value is for millimeters of mercury? What's the R value? Hey, good morning. So because of that, nitrogen gas actually is N2 in this case. And that makes a difference because it's twice the number of grams for the molar mass of nitrogen. It's not just 14.01, it's actually 28.02. So let's solve for the mole amount. So we have our grams at 65.85 grams divided by the molar mass is 28.02 grams per mole. And we got this value from doing 2 times N, which is 2 times 14.01. That number comes from the periodic table. All right, so if we are calculating, it's going to be if we're calculating, it's going to be 65.85 divided by 28.02. So I get 2.0 or 2.35, but sig fig wise, so it'd be 2.350. Okay, that's your mole quantity. So that is going to be your N value. Okay, so up here in N, you're going to write down your answer at 2.350 moles. Okay, N2. All right, and then your temperature is what we're trying to find. So remember, we're calculating this in Kelvin, but to get it to go back to Celsius, we need to subtract 273 from that value. That will give us degree C, right? So we are actually trying to find that variable right now. That's what we're trying to find. Okay? All right, so let's write it out. Since we already have our equation, we just need to plug it in at this point, okay? So we have our pressure unit is 1988. Our volume is 17.5 divided by our N value, which is 2.350. And our R value is going to be the 62.4 because it's in millimeters of mercury or torr. That will equal your temperature. And then we need to take that value and subtract 273 from that, and that will give you your Kelvin. Your Celsius. All right, so do this on a computer real quick. All of them.